we have talked about so far. Uh, Today, I would like to change our focus to look more on the summarizing data. We said that once you have collected data, you have to organize it if it is to make sense for you to be able to say sensible things out of that data. The second way of dealing with that data is to summarize it. So organizing data and summarizing data are parts of what we said descriptive statistics. You organize data in order to describe what you have observed, and you also summarize data in order to describe what you have observed in your data set. Now, summarizing data refers to coming up with specific indices. What are you saying here? You are saying things which you just want to waste my time. Let's go. Computers which are old, they're always causing problems. So, apart from the process of organizing data, the other way of describing your data set is to come up with some descriptive statistics used for summarizing data. And that process involves coming up with one index on your data set, which can be used to describe that data, or a few indices for describing that data. So, if, for example, you were looking for a particular attribute in a population of, say, 1,000 people, and you have collected data for those 1,000 people, you will end up with 1,000 data points. For you to speak about 1,000 data points, it may be difficult. So, coming up with a particular index would help you to talk about that. For example, income levels for area 15 people, 1,000 of them. And one of those indices which you can use is the measure of central tendency, which I think last time I started talking about them, that there are several measures of central tendency. We looked at a mean as one. We talked about a mode as another, and we talked about a median as another. Three types of measures of central tendency. These are measures of average. So when we talk about averages, we may mean a mean, we may mean a mode, we may mean a median. If you are talking about a mean and you call it average, then you should call it arithmetic average to differentiate it from the other types of averages. And we said the mode is a measure of average, which simply refers to the most frequently occurring score in a distribution. If in that 1,000 people, you measured their income and you found that the most frequent occurring level of income is 5 million kwacha. Maybe 300 of them earn an income of 3 million kwacha. Another 200 earn an income of 2 million kwacha. Another 200, 4 million kwacha, and so on and so forth. And you find that in that data set, the largest number is the 300. Then the 300 will be a mode, the most frequently occurring score in a distribution. In my example here, 11 is the most frequently occurring score. I remember I talked about this last time, eh? Yeah. But the mode is not as frequently used in statistics because of its instability. We saw that there is also a possibility that in one data set, you could have 2 modes, 3 modes, where you can talk about the bimodal distribution and the like. So if you have 2 modes, which mode do you use to describe your data set? It's instability. However, if your data set is measured in a nominal distribution, then the only measure of central tendency you can legitimately use is a mode. The other measures of central tendency would not be appropriate. Since we are revising it, this is a good opportunity to ask questions when something doesn't seem to make sense. The second measure of central tendency, the second average you can use is a median. And the median is a measure which refers to the point at which 50% of the scores in a distribution lie below it. So it is the midpoint. That definition implies that for you to come up with a median, you must organize your data into ordinal, starting from the lowest score to the highest score. So the score, which is at the middle, representing 50% below it, 50% above it, that score would be referred to as a median. So just like I've organized my data, lowest is 14, highest is 22. Then from there you count how many scores are there. The midpoint, which is 19, is the median. I guess that's straightforward. And for purposes of computing medians, each score is considered to be falling within a range from midway, from that point to the lower point, and midway from that point to the higher point. Such that if your data set is composed of an even number of scores, then it may be difficult to define the 50% below each point, because on one it will be one side more and the other side higher. So you have to compute between two scores where the midpoint is, and that's why we use the law of lower and higher limit or upper limit. I hope that is also clear. The other issue to consider is that when we are talking about a median, the values of each individual the value of each individual score is not taken into account. It is an ordinal statistic. What you are taking into account in a median is the position of the scores. Their values do not play a role in the computation of a median. Of course, just like the mode and the median, these are measures of averages which can be used when you have interval data, when you have ratio data, when you have all other types of data. You can use these measures, but if you have all nominal data, then you are only limited to usage of a mode. If you have interval data, then the only legitimate measure of central tendency would be the median. If you have the other two types of data, you can use the median in those data, but on the ordinal data, it's only the median you can use. I hope I'm making myself clear. So the type of data you collect influences the type of averages you can use. If you have interval data, you have also ratio data. People would expect you to use a mean, which is the best measure for coming up with a central tendency. But if your data is skewed, you may wish to use both the mean and the median just to help whoever is studying your data to know that this data set is not normally distributed. It is in a skewed distribution. Because in a skewed distribution, the mean tends to be influenced by the value of each and every score. So the scores which are outliers in that distribution will pull the mean towards the direction of skilledness. So the mean may not be a very good measure to show typical performance. The mean is a good measure for showing combined performance in a distribution. But typical, and when I'm saying typical, I'm looking at if you're looking at a population, where are the majority found in that population? If I'm looking at the heights of students at the University of Lilongwe, now the majority of those students, what height would they be represented by? Because we might have 4 or 5 students out of the 500 students who are exceptionally taller than all the other students. And that exceptional height they have will have influence on the mean. It will pull the mean towards them. But yet those are only exceptional students. The majority of the students are lower than that in terms of height. I hope I'm making sense, eh? If your data set is distributed like that, you know that the majority of the students are within that area. Okay? But there are a few students who have performed exceptionally higher than this. Now, if you compute a mean, because the mean takes into account the value of each and every score, so the values here will be taken into account into that mean. So the tendency will be that the mean will be pulled towards this direction because of this. But the median, since it is measuring the point at which 50% of the scores lie, you'll find that it will be towards that. Whilst the mode will still remain where the largest majority are at, where the majority of the scores lie. So that will be mode. That will be median. And that would be mean. So in terms of talking about the typical performance, the median will be talking about the typical performance because it is talking about 50-50. The mode will be talking about the commonest, the largest number of scores. Now, the score with the largest number of observations. So that is what is going to happen. Similarly, if you have a negative, by the way, last time when I was talking about this, which one did I say is a negative skewed distribution? I may have confused you. This is a positive skewed, this is a negative skewed. If you have this again, you'll find that the mode will still remain where the scores are most occurring. The median, because it is talking about the 50%, and these part and parcel of that 50%, it will be pulled a little bit, but not too much towards that. But the mean will tend to be pulled more towards that because of the fact that the individual scores, the values of the individual scores are being taken into consideration. So that's what I'm saying in that. Make sense? The implication is when you have collected the data and you want to compute a measure of central tendency, an average, first inspect the data. And the sort of inspection I'm talking about is to plot it in a graph so that you know the type of distribution you have. And therefore you can describe it better. Because if you have in your inspection, you find that the data is normally distributed. Are you going to do a better job for me? In a normal distribution, what happens is that both the median, the mode, and the mean will fall on the same place. This line, I'm not a good artist. Yeah. This line will be representing the point at which the majority of the observations occur. At this same point, it will be representing the point at which 50% of the scores lie below it. 50% of the scores lie above it. This point will also represent the average performance, the performance which represents the way all the students in this distribution have performed. Okay? And if you find that your graph, your distribution is normal, then you do not have to worry about computing a mode. You do not have to worry about computing a median. You know that the mean is talking about all those. Okay? But where you have this or that, you need to show the mean and the mode. If what I gave you last time, I labeled them wrongly, this is the most correct way. Make corrections. And I'm just demonstrating what I'm showing there in this example. If you look at that, the majority of the scores lie between 49 and 57. But there were these two outliers who performed completely different, away from the way most of the students typically performed. And because of that, computation of a mean comes to 62, which is far away from the majority of the students. But the median is not affected that much. It is affected, but it's not much. Okay? because of Chokapa Media Net, we can move further to talk about what we have normally talked about since primary school. But it's the most loved index in statistics, and that is a mean, which is the sum of x divided by n. I think I gave you this formula last time, right? The mean is normally represented by x bar. If you see x bar, you know that we are talking about a mean, eh? Yeah. You know what this is? Sum of it. Sum of x divided, you know what this is? Number of scores. Actually, I'm wrong, right? This x should be x bar, small x, okay? But you can also have capital X, right? Now, if it is capital X, x divided by capital N. We are talking of the mean in both cases. But what is the difference? I think I talked about that earlier on sometime. What's the difference between the two? Why would you, in one case, want to use capitals and in another case want to use small letters? Zinadi Bwandi. I think at one time I was talking about parameter and statistic. You remember that? In our definitions, when we said a parameter is an index used for what? When you're dealing with a population, we talk about parameters, right? When we're dealing with a sample, we talk about statistics. So this formula I'm using here is for a statistic. This one I am using here is a parameter. In my example of measuring heights of students at the University of Lilongwe, if I measured each and every student, and after measuring their heights, I compute a mean, then the formula should look like this one. Because we are talking of the whole population of university students at the Lilongwe, the University of Lilongwe. Okay? But if I said instead of measuring all the 500 students we have at the University of Lilongwe, I'll take a sample. So I'll go to year one. Out of 100 students, I'll sample 20. Year two, I'll sample 20. 3, I'll sample 20. 4, I'll sample 20. Then I have a set of 80 students. and I measure the heights of these 80 students. But my interest is the University of Lilongwe, and I've used a sample because of the various limitations that I may have. Then, when I'm computing the mean, the formula would be a statistic. Great. You will ask. So, when we are talking about the mean, it's the sum of all values in the distribution divided by the total number of cases, or the total number of observations. The N is the number of observations, and the sum of X is the summation of the values in the distribution. Did we talk about the mean last time? We had just started it. This is where we actually stopped last time. So the mean is referred to as an interval or ratio statistic because of the fact that we are looking at the value of each and every score. When I was talking about the value of each and every score, this is summation. It means that the value of each and every score has been taken into consideration. Okay? And by dividing by n is just to say, now let's look at the central performance of these scores. So it is not a nominal statistic, and it's not an ordinal statistic. It can only legitimately be used in interval and ratio data. In fact, strictly speaking, using it in interval data has a problem. You remember the problem we talked about? It's used, but it's not the best way of using it. Our colleagues in the Department of Meteorology are always using it. The average temperature in Lilongwe, the average temperatures in Nzuzu are, so they're using the mean rate, but there's a problem. You remember what the problem is? Interval data does not have a true 0 point. So the multiplications are only convenient in terms of the measuring instrument. But the measurement of the actual attribute of heat, we are lying. Okay? So whilst the mean is a very good, is the best measure of central tendency, but it can only be used in ratio statistics, ratio data, and interval data. This is a very important aspect that we need to get out of this class 8. If you are using ordinal data, don't compute a mean. And here I'll pick you in the education on sport, because that you are likely to suffer. You administer a test and you get marks from those students. Usually what people want to hear is who was the best performer, who was the poorest performer. In fact, the interest more is on the best 8. So you are forced to convert those marks into ordinal data, and you order them from best to poorest performer, 1 to 150. But you cannot use that scale you have created by ordering those students to compute a mean. If you want to compute the mean performance of these students, go back to the original data of marks and compute it from that. Okay? If you compute a mean from the ordinal data, it will be meaningless. Any questions about these 3 measures of central tendency? A very crucial step in conducting descriptive statistics. We'll come up with a measure of central tendency, which will help you to describe the whole data set using one score, one index in the score, in the scores, or in the distribution. And if you want to compare these 3 types of measures of central tendency, then the mean is considered to be the most precise measure of central tendency than the median, which is only an ordinal statistic, or the mode, which is only a nominal statistic. It is the most precise measure because it takes into account the value of each and every score in the distribution. And because of that, it is the most stable measure in a distribution. If you have a distribution and you compute the mean, unless you have made mathematical errors, you cannot come up with 2 means. It will always be 1 mean in that distribution. Okay? So when you're describing the distribution in terms of the mean, you know that apa takamba zonse. And as I was saying earlier, the mean is a good measure of the combined performance. And I'm saying combined because each and every score, the role of that score, the value of that score has played a role in the computation of that mean. Okay? So it is a measure of combined performance. But if you're talking about a measure of typical performance, then the median. When you talk about the median, you know that at least 50% of the population was below this one. 50% of the population was above this one. Okay? So very typical. Which I've just said. Best indicator of combined performance, mean. Best indicator of typical performance, median. And what I'm saying in the last bullet is what I was showing there. Okay? The mean and median will fall on the same values of scores in a symmetrical distribution here. If you have a symmetrical distribution, when we're talking about symmetrical distribution, we're talking about a normal distribution. So the mean, the median, the mode will be on the same place. But when you have skewed distribution, or a distribution where there are extreme scores, then the mean will tend to be pulled towards those extreme scores. These extreme scores are pulling the mean towards it, whilst the mode is not affected. The median is also affected because of the part and parcel of the 50%. So it is affected, but not much as affected as the mean. The mean tends to be more affected. Okay? Similarly here, the mean is more affected by those extreme scores. The median is affected, but not much. The mode will still remain where the most frequently score is occurring. Those are things which, when you compute in your data and you find that the distribution looks like that, you should be able to be describing. Because by the mere fact of the position of the mean, median, and mode, you should be able to describe, even without the graph, to say that this is a data set which is skewed, and it is skewed negatively or skewed positively. Mafunso ziri bwinobwino omukazi onekaye ya zioneni ndikupasani 5-10 minutes mukuziona. After 10 minutes tifuta ndetifusana mafunso. Akhala part of assignment. 10 minutes break. So, as a always saying before we broke off, in a negative skewed distribution, the mean will have the lowest score. And the median will have a lower score than the mode, because as I was saying, the mean is the most affected by the scores that are on the extreme side. Similarly, on the positively skewed distribution, the mean will always have the highest score. And the median will also be affected by the skewedness, but less, whilst the mode will always not be affected by the performance of the individual scores. That's what they say. Demonstrated by what we are showing here. Okay. No, that's different. Any questions about central tendency? Measures of central tendency? If I go to another set of measures used for summarizing data. So the measures of central tendency, they help us to give an idea of the average performance in a distribution. Okay? The mode gives us an idea of the average performance. The median, similarly, an idea of the average performance. But the best measure of average performance would be the mean. And especially if you have a normally distributed a normal distribution, normally distributed scores in a distribution, the mean will be very helpful. But even in the skewed distributions, if you are dealing with the data which is interval or ratio, you want to use the mean, but you may have to use it in association with another measure of central tendency, the median. Okay? The second aspect which people get concerned about when they are looking at the scores in a distribution is how far apart are the scores falling in that distribution. The further apart the scores fall, the more variability in that distribution. The closer together the scores are falling in a distribution, the less variability in the distribution. And when I'm talking about the variability, is the Oceania. Yeah. So if you have administered an exam in mathematics and you find that somebody has scored 20%, somebody has scored 90%, somebody scored 80%, there is a lot of difference between the performance of these students. So you can say there is variability in the performance. Some are extremely good performance. Some are extremely bad performance. Some are mediocre performance. I need of mediocre. Mediocre means extremely bad. Yes. Yeah. Some are middle performance in that distribution. But if you administer the same exam in another class and you find that the lowest performer got 88 and the highest performer got 91, then this group of students are not very different in their performance, isn't it? They are performing very close to one another. Actually, the one who has scored the lowest score, if next time around you administer another exam and you find the one who got the lowest score getting the highest score, you will not get very much surprised. Because these guys, their performance is very close. They are competing. But if somebody is 20%, somebody is 94%, and you administer another exam, the 20% gets 98%, you can have a question, because there is a lot of variability in their performance. So the measures of central tendency do not help you to assess the variability in the scores. In the distribution A, for example, the lowest has gotten 24, the highest has gotten 26. So the scores are ranging within 2%. But if you look at all these scores and you compute them in, you get 25. Distribution B, the lowest 16, the highest 35. There is a lot of differences in performance. Computer mean 25. So the mean is not telling you how different the performance is in the distribution. It's only telling you the combined performance or a typical performance in the distribution. If you were to compute the difference between the highest and lowest score, then you will begin to have an idea about mean. Although they have the same mean, but these two distributions are different in nature. Because the 35 minus 16, 98. If my mathematics is correct, it's 19. 35 minus 16. Oh. I can calculate 6. Yes. 90. Okay, so yeah. So 90 versus 2. Here the difference between the highest and the lowest is 2. Here the difference is 19. It means that there is more variability in this distribution because the range is larger. Now, when you are talking about the measures of variability, there's also several measures you can use for assessing variability in the distribution. One is the one I was using in my example, range. The difference between the highest and the lowest score is referred to as a range. And you can also use the quartile deviation. You will see how to compute that data, which is also another measure of variability. The most commonest measure of variability people talk about is variance